All right, so we're going to start off with our very first key drawing, which is going to be our ball at the high point. So what I want you to do is roughly about an inch, inch and a half from the top of the sheet of paper, is I want you to draw a circle. Oh yeah, the first thing we should do is actually we should find our path of action for this, and just to make things easy, what I want you to do is take your sheet of paper and just fold it in half. So line up your peg holes, so your square hole pegs are lined up there, and just crease your paper very lightly. Doesn't have to be a really firm crease, but just a light crease to give us an idea of where the center of the sheet of paper is. So you can see when I drew my initial circle there, it's just slightly off center. I want to get back on center again. So just lightly draw a circle, roughly about the size of a toonie. Now this is something that I say to the students at the very beginning of the year whenever we're working on this assignment, is I want you to get used to the idea of drawing a circle, like an actual pure circle. This is going to be one of the basic shapes that you're going to be using in animation. Anytime you're doing any character animation of any sort, your two basic shapes are circles and cylinders. Okay? That's what your character is going to be made up of. Your character's head is going to be made up of a circle, their body is going to be made up of a circle. We're going to connect those two together with a cylinder, maybe bend it a little bit. So there's the body of the character. The legs will be made up of cylinders. Arms will be made up of cylinders. Hands will be made up of circles. Feet, sort of a half circle type thing. Okay. So those are your basic shapes that we're going to be using. So the more comfortable you are with drawing a circle, the better off you are. I don't want lumpy circles. I want nice clean circles. So what I'm going to allow you to do at this point, since we're just dealing with something very, very simple, is if you're having a real hard time drawing a circle, which you shouldn't, pull out a toonie and trace it, okay? Or a loonie and trace it. Or if you've got a circle template, use a circle template to get your circle correct, okay? So I don't want your circles to be malformed, meaning that I don't want a circle that looks like a potato, okay? It should be a circle. Right? Now there was one time, I told this story, I always tell my students this story, that when I was teaching at Sheridan College, we had the same basic assignment, and one of my students said, "I'll bet you can't draw a perfect circle just in one line." And so I took a sheet of paper and I went, "Well, let's see." And I went, and I can't do it there, but I drew it, and it was the perfect circle. Like, it was absolutely perfect. Everybody went back and they go, oh, he's amazing. He's like a wizard of some sort. And I said, yeah, that's a once in a lifetime happening. That'll never happen again. And it hasn't. I haven't been able to duplicate that since. So you'll notice that when I'm doing my circle, I'm being very loose and roughing it in. So I've got a very, very fuzzy circle. But as I begin to zone in on what that circle shape is supposed to be, I begin to solidify my line and darken it up a little bit more. Okay? So I'm okay with something like that. You can have a fuzzball line if you want to. Now, this is going to be our drawing number one. Okay, we're not going to call it A because we know what it is. It's the first drawing. So down in the bottom corner here, I want you to put a number 1, and because it's our key drawing, I want you to put a circle around it. Whenever we put a circle around a drawing, that means that it is the key position. It's the extreme position that that ball is going to be in. So in this instance here, our ball is starting up at the high point. It's going to drop down to the ground, hit the ground, squish, and then recover, come back up, and it's going to stop in this exact same position. So this is the extreme high point of the ball. All right? Now what I want you to do is take a separate sheet of paper, place it over top. And what we're going to do is we're going to find the low point of the ball. And the low point, I want it to be roughly about an inch and a quarter above your peg hole. So find your center, roughly about there. And here's what I want you to do. I want you to take your drawing and place it over top of where your other original circle was. You should be able to lightly see the circle through it. But we're not going to trace this circle off. Okay? What I want you to do is I want you to use it for reference, because we're going to squish this ball by turning it into an oval. So what I want you to do is roughly about from the bottom of the ball to the center, is I want you to lop off about 1/3 of the volume of it. And the same thing on the top. Take off about 1/3 there. So we're going to flatten it a little bit like this. And then what I want you to do is expand that out to the side there, roughly about a third out to the side. And about a third out on this side as well. So we now have this elliptical shape. Right? So when you take and flip the two drawings now, it'll look like your ball is just squishing on the spot. Now the reason we did the 1/3, I don't usually say this, but the general reasoning behind this is that we're compressing the ball. We're pressing on the bottom and the top, which is displacing the volume. We're squishing it, so therefore the overall volume of the ball has to go somewhere else, and it's going to expand out the two sides. So that's why we're taking the width out wider on the outside edges. What you don't want to do is this. You don't want to take and lop off a third off the bottom, lop off a third off the top, and then keep the outer edges the exact same size, because then what ends up happening is your ball ends up shrinking. So between these two here, the top and the bottom shrink, but there is no displacement of the volume. And so what it creates the illusion of, if you can think of it in these terms, is it looks like we're looking at, let's say, a toonie standing straight up on its edge. And then what we're doing is we're pushing it and making it fall over, so it's falling away from us in a 3/4 view. So the volume, the width of it is exactly the same. It's just as though we're looking at the bottom edge here and it's falling away from us, like it's flipping. Okay? So we don't want that illusion. What we want to do is we want to create the illusion that the volume is actually being displaced to a different place and it's moving out on the sides. Right? So once again, I want you to try and maintain a nice smooth oval here. Try and make it as even as possible. And again, here are the different variations of things that I sometimes get. I will get this. I don't want to see a loaf of bread. Okay. I also don't want to see this. I don't want to see a pointy end football. And I don't want to see this. Mr. Lumpy Potato. Okay? So it's a very, very simple shape. You just smooth it in like that. So when you flip your two drawings now, we have a movement from the top down to the bottom. So we've got a distance that's being covered here. So just by doing this with these two drawings, we are creating an illusion of movement, but it's not a smooth movement. Okay, it's just a jerking action up and down. So what we want to do is we want to drop this ball from this position down to this position here. Now once again, we don't know the number of this drawing. I know because I've been doing this every year and I know what the number is, but for you guys, you don't know what the number is. And we need to figure out what that number is going to be because we only have two key drawings. So now we have to determine what our timing is going to be. Excuse me. So back on drawing number 1, I want you to draw a little short line just above the number 1 and then draw an extended line that comes up like this to approximately there. And put another little line on top of it. This is going to be our timing chart. Timing charts are used in animation to determine the amount of space and time, not necessarily the space, because the drawing itself determines the spacing, but it determines where we're going to put the individual drawings that go in between the two main keys. And it also determines the speed at which these drawings are moving at. So what we're going to do is we're going to drop in a series of in-betweens here to determine the amount of time. Now you'll remember when we first introduced the course, we talked about in animation that you normally shoot your animation drawings on what's called 2s. You expose your drawings for 2 frames. So that means that drawing number 1 here, when we go to shoot it on as a pencil test, we're going to expose it for 2 frames, which means that it's held on screen for 1/12 of a second. 1/12 of a second is not a lot of time. 1 second is like 1/1000. That's 1 second, right? So 1/12 of a second is a very, very short blink of an eye. And so we have to figure out how many times do we want this ball to bounce within 1 second. So why don't we just say we want it to bounce once every second, right? Which means that we're dealing with 24 frames a second. Shot on 2s means that we have 12 drawings total. So that means going from here down to the bottom and then back up again, we want it to go over 12 drawings. All right? So that's our overall timing that we have. We just determined that in our mind based on, well, I want the ball to bounce like this. 1. That's about a 1 second bounce. Okay? Now again, depending on the type of ball that you have, it will bounce differently depending on what it's made of. So if we had a beach ball here, we'd probably bounce it much slower. It would be more like something like that. Okay? Maybe 1 3/4, or maybe even 2 seconds per bounce. But in order to make this a little bit more easy for you guys, we'll just stick with the 12 drawing rule. All right? So we need to get this ball from here down to the bottom and then back up again. So in order to do that, we have to fill it in with a number of drawings. Now, as a general rule, and I'm just going to use this as a general rule at the beginning, just to introduce you to the idea of in-betweens. As a general rule, we always place our first in-between half the distance. All right? In-betweens are usually placed in half distance increments because it's easier to figure out where half the distance is on any given line. So as an example, let's say I have a sheet of paper here and I just draw a line like this and I draw a line like that. It's pretty simple to figure out where the halfway point is. You just simply look at this end point here and this end point here. You can measure the distance and find the exact halfway position. And then connect the 2 points together and ta-da, you've got your halfway point. Right? But if I said to you, okay, here's 2 lines. Here's a line here and here's a line here. Draw a line 1/12 the distance in between those two. That would be a little bit more difficult. Okay? You'd actually have to measure out in half increments. You'd have to split it up so that this would be your distance here. You have to divide that in half, divide it in half again, divide it in half again, divide it in half again. So that's half, quarter, eighth, 16th. So I'd be somewhere in between those two. So that actual position there would not be accurate. So finding a 12th, or even an odd number, a 13th, ugh, that's kind of creepy. Okay? So we always split things up in halves, just to make things easy. So our first in-between is going to go half the distance. Now, remember, we're dropping this ball from the high point to the low point. So if we're going back up and it's taking 1 second, going down is going to take half a second, right? So half a second is 12 frames or 6 drawings. So from here to here, we have to fill in 6 drawings. So there's drawing number 1, this is drawing number 2. We need a bunch more drawings in here in order to fill that in. Now, when the ball starts at this top point position here, we have what's called an acceleration point. It has to accelerate from a dead stop position. It has to speed up. So the idea is that when, the analogy I always give the students is, when you're sitting in a car and you're driving, well, you're not driving, you're just sitting in your car. You hop in your car, stick the key in the ignition, turn on the car, and your car is in park. You put it into drive, and you step on the gas. Are you immediately going 100 kilometers an hour? Like you step on the gas and all of a sudden, 100 kilometers an hour. No, you can't do that. Because the rate of acceleration would be so great, the G-forces affected on your body would cause your eyeballs to be pressed into the back of your head, and you'd die. Okay? So you'll notice that when you step on the gas, your speedometer will go like this. It gradually speeds up to the point where you're going the speed limit, okay, or beyond, depending on how you drive. But we have this acceleration where it gradually builds up to the speed of the constant rate that we're going. So the same thing is true when you drop something. When you release it, it doesn't immediately go its fastest speed. It gradually builds up speed as it drops down. So what ends up happening is we have to split this up. Half the distance between here and here would be there, and then half the distance there would be there. So just by doing that, the distance from here to here is greater than these two distances individually. Okay, this overall distance is the same, so that would make it moving it as a constant rate. By doing this, we're slowing in the action. But this is not enough, because now we have 2 drawings in between, and what we need to have is we need to have this drawing here has to be number 7, so we've got to fill this in. So this is number 2, so by dropping in a drawing in between here, this is number 1, this is number 7 down here. This is our halfway point here. We need another drawing in here. So this drawing goes into this position here. For number 1, we're slowing in. So So we're going to drop in another in between right here. So now we have 2, 3, 4. So we still need 5 and 6 put in. So we're going to put one more drawing in here. And then what we're going to do is we're going to put a drawing over here. Very, very close to the number 7. And the purpose of this one here is it's called a favor. And we usually put an F beside it. It's also like a cushion. A cushion, in real world terms, is something that you put on a couch to make when you sit down nice and soft, right? So if you were Fred Flintstone, living in Fred Flintstone's house, and you had that rock slab couch, and you jumped and landed on it, that would be a pretty hard hit, wouldn't it? You'd go clunk, and it would hurt. So you throw a nice cushion on it with nice fluffy feathers in it, or sponge or whatever, and you jump on it and you go, ah, and it's nice and soft. So the purpose of a cushion or a favor in animation is just to soften up a movement into a key position. So that's why we're putting this one over here. And I'll explain more of that when we get to the drawing. So now we have drawing number 2 here, number 3, number 4, 5 is the halfway position, and we're just going to draw a little line underneath that to indicate that it's our breakdown. And then number 6 goes in here. So now we're up to number 7. So this is drawing number 7 now. And we put a timing chart on this one. And we have to fill in our in-betweens from here back up to number 1, because we're coming from here back up to that position. So again, as a general rule, we always start off with a halfway point. We also know that we want to have this slow-in action taking place here, but it's going into number 1. So we're going to put another halfway or a quarter position there, an 1/8 and a 1/16.